So basically, the transaction is a collection of operations that forms a single logic unit of the works. Uh, of course, that single logic unit of the works, if you take an example, and the example is the fund transfer, then what used to happen that from where the amount has to be debited, it will be checked first, and then uh, it also has to check that the account which has to be credited, whether there is any bar on that or not, and then it will do the. So what used to happen that the total uh, balance of the account should not be different, because the amount which is debited has to be credited into another account, so that the total balance of the bank should remain as it is. So you can say that transaction is a unit of program execution that is going to accesses, and possibly it is going to update the various data items. And usually the transaction is being initiated by a user program, which is written in the high level language. Um, and the different transaction which used to take place in between the different statements, it starts from the begin transaction and the end transaction. So all the transaction which are consist of the different operation which has to be executed, it has to be in between the begin transaction and the end transaction. Now, whenever we do transaction, we have to ensure the integrity of the data, because we want that the database system to remain consistent while doing any kind of transaction. So the transactions has is essentially different properties, and out of that there are 4 properties which are called the ACID properties. And out of that, the first property is the atomicity, because, and now what is the atomicity? Because it is the atomicity property which tries to ensure the to the outside world that all the operations which are happening in a transaction appear to be performed indivisibly, whatever number of operation is being performed in a particular transaction. So if there is any kind of failure, then the atomicity is going to maintain that whether whatever transaction has been done, it has to be fully done or it is not done. So the atomicity actually means that either all the operations of the transactions are reflected properly in the database, or none of the transaction, none of the operation should be reflected in the database. Now, the second property is the consistency property, which tries to ensure that while there is any transaction which is in progress, and other processes which are executing concurrently with the transaction, which are not going to modify or not going to observe any kind of intermediate states of the transactions. Only the final states become visible to the other processes after the transaction is being complete. This is also related with the concurrency. So this consistency or the concurrency is also known as the consistency property, because a transaction moves the system from one consistent state to another consistent state. The third one is the isolation. This property ensures that the concurrently executing transaction do not interfere each other. They should be done separately or in sequentially. For example, if we take any pair of transactions as T1 and T2, it appears that either T1, it appears to T1 that either T2 has finished the execution before T1 starts, or the vice versa. And the fourth property is known as durability. Durability property ensures that once a transaction is being completed successfully, the result of that operation becomes permanent and cannot be lost even if there is a there is a corresponding process or the processor on which it is running, it is going to crash. So even if, since it has completed successfully, it has to recover back, and that is the meaning of the durability. It has to recover back, and so all the lost things should be. So after a transaction completes successfully, the changes which has been made in the database should persist even if there is a failure in the system. So that is the meaning of the durability. Now, these properties are called, as I told you, if you take the first letter of all these property, A, C, I, D, it is called ACID property. And this acronym is defined from the first letter of each of the 4 properties. Now, moving ahead to the consistency and the isolation. Now, the database consistency is a certain kind of the property that every transaction sees a consistent database instance, and it follows from the transaction atomicity, isolation, and transaction consistency. And most of the cases, users are responsible for ensuring this transaction consistency, meaning thereby the user who is going to submit a transaction before it must ensure that when it is about to complete, when it is going to run to the completion of itself against a consistent database instance, the transaction will leave the database in a consistent state. Now, if we want to take an example, we can discuss it like here, that the user may have the consistency criteria that if I take the example of a bank transfer, fund transfer, so user may have the consistency criteria that the fund which is being transferred between the bank account should not change the total amount of the bank. So to transfer the money from one account to another account, the transaction must debit one account, and temporarily, at that particular moment of time, temporarily it will be leaving the database inconsistent in the global sense, because it is still not credited that amount into another account. So in the global sense, at that particular time, temporarily the database will be inconsistent in the global sense, even though the new account balance it is going to satisfy any integrity constraint with respect to the range of the acceptable account balances, because whenever you are going to credit, there must be certain constraint which has been imposed that you cannot credit the amount up to this limit. So as far as the users are concerned, the consistent database is preserved when the second account is credited with the transferred amount. But if there is a transfer program which is a little bit faulty and going to credit the second account 1 rupees or 2 rupees less than the amount which is debited from the first account, then in that case, database cannot be expected to be expected to be consistent, and it will detect inconsistency just because of the error lying in the user's program logic. Now, as far as the isolation property is concerned, the isolation property is ensured by guaranteeing that even though the action of the several transactions might be interleaved, the net effect should be identical to executing all instruction one after the other in a particular serial order. Now, if we take an example, if there are 2 transactions, T1 and T2, which are executing concurrently, the net effect is guaranteed to be equivalent of executing all T1 followed by executing T2, or executing all T2, all of the T2 followed by executing the T1. And each transaction maps a consistent database instance to another consistent database instance, executing several transactions one after the other, and that is going to result a consistent final database instance. Now, the next one is the atomicity and the durability. Now, there is a possibility that the transactions are not going to complete at a certain moment of time, and there may be many reasons. Basically, there are three reasons by which the transactions are not able to complete. The first is that the transaction uh, is being aborted or terminated unsuccessfully by the database management system itself, because some anomaly have been has arisen during the execution. Now, if a transaction is being aborted by this database management system for some internal reasons, it is automatically restarted and executed the new one. The second reason may be that the system has been crashed. It may be because of the power supply is interrupted while one or more transaction is in progress. And third possibility is that the transaction may encounter an unexpected situation, uh, and it has decided to abort or terminate itself. So just because of the three reasons, it may be possible that the transaction which is under process is being aborted. Now, as far the users are concerned, user think that the transactions as whatever is being executing, it should be atomic, and the transaction is being interrupted in the middle way, leaving the database in the inconsistent state. So therefore, what will happen? The database has to find a way to remove this effect of the partial transactions from the database, which had happened before the crash. So uh, the transaction must ensure the atomicity. Either all the transaction actions are carried out or none of them are carried out. So this database management system ensures the transaction atomicity by undoing the action of the incomplete transactions. So it means that the user can ignore the incomplete transaction by thinking that how the database is being modified by the transaction over the time. So just to solve this particular problem, the database management system used to maintain a record, and that record is known as log, which has all the rights to the database. It is going to maintain the record which has happened because of the writing process in the database. So all the rights are stored in the logs, and this log is also used to ensure the durability also, because if the system is going to crash before the changes has to be made, or the transaction has been complete and changes has not been done, and it has to be written on the disk. So in that particular case also, the log is used to remember and restore all these changes whenever the system is going to restart. And the database management system component that ensures this atomicity as well as the durability is known as the recovery manager. Now the transactions and the schedules. Now, as far as the transaction is concerned, and in perspective of the DBMS is concerned, the DBMS sees the transaction as a series of the action or the list of the action. And this action can be executed by a transaction by including the reads and the writes of the database objects. Now, if there is an object O and it has to be read or it has to be write, the program variable which will be using O to name the object. And if there is a transaction which is related with the object O, it has to done the reading operation, then that transaction can be represented as RTO. And similarly, if it is a writing operation, we can say it as a WTO. And when the transaction is clear from the context, we don't use this T as a subscript of RTO or WTO. Now, besides that reading and the writing, every transaction must specify also its final action, that is the commit action, the completing completeness or the successfully completeness, or the abort, which is the mean by the terminating or undo all the actions. Now, we were discussing about the schedule, that what is the schedule. So schedule, you can say that it is a list of action represented in the form of a set which contains reading, writing, aborting, or committing. And this can be called as a set of transactions. And the order in which two actions of a transaction T appears in the schedule must be same as the order in which they appear in T. So it means that the schedule represents an actual execution of the sequence. Now, if you take an example, suppose we have two transactions, T1 and T2, and these T1 and T2 are the two transactions, and we move forward in time as we go down from one row to the next row. Now, I'm going to emphasize that how the schedule describes the action of the transaction, which is being seen by the database management system. And in addition to these actions, that is reading, writing, aborting, and committing, the transaction may also carry out the other actions also, such as reading and the writing of the operating system file, evaluating some arithmetic expressions, and so on. So, of course, we assume that these actions do not affect the other transaction. That is, the effect of the transaction on another transaction can be understood solely in terms of the common database objects that we want to read or that we want to write. So here we have an example in which schedule has been represented. T1 is a transaction, T2 is another transaction, and the T1 transaction is reading of A is an object, then writing of B. Of course, there is some mistake. It is not B, it is A actually. So first of all, whenever T1 is executing, so RA means reading of A, then writing of A, then reading of C, then writing of C. Then in transaction 2, we have reading of B and writing of B. So this is a kind of a schedule. This is a kind of a that how T1 will execute row by row, and how T2 will execute. First, it will read A, then write A, then read C, then write C, then read. The T2 will be read B and write B. So this is an example of the schedule in which the two transactions are executing. Now, as we see that in this particular schedule, we don't have any abort or the commit action of either of the transactions. So we can define that a schedule that contains either an abort or a commit for each transaction whose actions are listed in it is called an complete schedule. But this is not a complete schedule because no abort or the commit action has been shown. And if the actions of the different transactions are not interleaved, these actions are not interleaved, the transactions are executed from start to finish. It will start from this and it will finish at this, one by one, and that is called it. So this is an example of the serial schedule. Now the concurrent execution of the transaction. Now, just we have seen that what is the concept of the schedule, and with the concept of this schedule, we can be able to describe the interleaved execution of the different transactions. And this database management system interleaves the action of the different transactions just to improve the performance. But every interleaving is not allowed. Every interleaving is not allowed, because we have to see that what kind of interleaving can be allowed and what kind of interleaving cannot be allowed. So in case of concurrent execution, the interleaving which are allowed are represented in this two form. Now, if you take care of this particular example, in this example, this represents an interleaved execution of the two transactions T1 and T2, and ensuring transactions isolation while permitting such concurrent execution. It is difficult, but it is necessary for as far as the performance is concerned. So, what kind of interleaving is allowed? The first one is while one transaction is waiting for a particular page to be read from the disk, the central processing unit can process another transaction. Why it can be interleaved means how it can work parallelly, because we know that as far as the input output activity can be done in parallel with the CPU activity in any kind of the computer, because they are not interlinked together. Because overlapping of this input output activity in the CPU activity, it is going to reduce the amount of the time with which the disk and the processors remains ideal, and increases the system throughput. And the second one is that interleaved execution of a short transaction and a long transaction. Usually, it is going to allow the short transaction to complete quickly. In case of serial execution, short transaction will be stuck behind the long transaction, and it is going to lead to in the delay, predictable delay in the response time, or the average time that is taken to complete the transaction. So two cases can be allowed, in which one is the parallel operation which is being done in between the input output action along with the CPU action, and short transaction versus the long transaction. It is always preferred to do the short transaction prior to the long transaction. Now the serializability. Now a serializable schedule is a different kind of activity in which we are trying to discuss about the serial schedule or the complete schedule, because the foremost requirement is to put the database state into a consistent state. So if we want the database state to be consistent, it is necessary that every transaction which is happening, which is in under the action, it is going to preserve the database consistency with complete serial schedule. So what is the serializable schedule? So we can define the serializable schedule over a particular set S of committed transaction. I'm talking about the set of committed transaction. So this serializable schedule is a schedule whose effect on any consistent database is guaranteed to be identical to that of some complete serial schedule over the set S. Meaning thereby, the database instance that results from executing one schedule is identical to the database instance that results from executing the transactions in certain sequence or in some serial order. So let us have an example of a serializable schedule. This serializable schedule has been shown in this particular figure, that in which we have two transactions, T1 and T2. The T1 transaction is reading A. A is the object, writing A is again object. T2 transaction is reading A, writing A, and then T1 is having a transaction as reading B. B is another object, writing B, and it is committing. Similarly, T2 transaction is reading A, writing A, reading B, writing B, and commit. So we have certain actions which has to be taken in transaction T1 and in the transaction T2. Even though the actions of this transaction T1 and T2 are interleaved, the result of this particular schedule will be equivalent to running T1 in entirety and then running T2 entirety. So meaning thereby T1 is going to read and write of B is not influenced by T2's action on A, because what is happening here, T2 is writing A, and after that, if these two transactions are interleaved, so what will happen in the interleave? First RA, then WA, then RA and WA, and then RB. So this RB and this WA is not going to affect anything, because it is writing A and it is reading B. So that is what is being said, that T1's read operation and write of B, T1 read operation and write of B is not influenced by T2's action on A. So the net effect is the same if the actions are swapped. If we swap the action will remain same. So the serial schedule we can form as T1 colon T2. Now, as far as the execution of the transactions serially in the different orders, it may be possible that it will be going to give the different result. But all are presumed to be acceptable because the database makes no guarantee about which of them will be the outcome of the interleaved execution. So we can go with another example. And this schedule is also a serializable schedule. Of course, it is a little bit different, but it is a valid one. Here, in this T2 transaction, first reading of A, then writing of A, then reading of A in T1, then reading of B and writing of B, then writing of A and reading of B and writing of B and commit and commit. So this particular example can be interleaved as is this particular example can be interleaved as shown by this particular example. And this schedule, which is shown in this particular example, are also serializable, and it is equivalent to the schedule T2 followed by T1. So if T1 and T2 are submitted concurrently to the database, either of these schedule can be chosen because both the schedule are serializable schedule. Now, as far as the definition which I have stated in the previous slide, that that serializable schedule over a set of committed transactions. So it means whenever we are talking about serializable schedule in this definition, we are talking about only the committed transaction. So we are not discussing, we are not considering right now, we are not considering the aborted transaction. So this is only for the committed transaction. So now let us discuss about the anomalies which can happen due to the interleaved execution, because there is a possibility. If we have a two transaction and the two transaction is working only read and read mode, then there will not be any anomaly. Anomaly arises whenever out of the two different actions of the different transaction, one is the right one. If one is the right one, so there are many possibilities. Either we have read read, we have read write, write read, or we have a write write. If in any of this is having one write at least, then the anomalies can be framed in the interleaved execution. So there are three main ways in which a schedule which is involving two consistency preserving committed transaction and could run against the consistent database and leave it into the not inconsistent state. So we have two actions on the same data objects which is going to conflict if at least one of them is right. And there are three anomalies. One is write read conflict, second one is read write conflict, and another is the write write conflict.